Hello everyone, this is Alfio Sando. Today I'm going to talk about 3 ways to implement factory pattern. If you like these videos, please support me by subscribing my channel and click likes for the videos. You can find the code for the examples in these videos at below, and also all my video links description below as well. Factory pattern is a frequently interview topics during software engineering interview. It's widely used in object-oriented design. So these patterns basically helpful to implement the polymorphism and help to create the correct derived classes. I'm going to show an example to help you understanding what is factory pattern. For example, if the interviewer asks you to calculate cost to fill a gas tank of a vehicle, then for different type of vehicles, the way to calculate cost is different. For example, for gas car, you maybe take 5 multiply the whole tank size. Then for hybrid car, maybe the different price for, say, for half tank size, you will cost $5 per gallon, say. Then for your half tank size, then afterwards, you only will be cost $2 for half tank size. Then for electric car, maybe there's different as well. I'm going to introduce how to implement factory pattern by Python, but I truly believe you can use a similar way to create factory pattern in other programming languages such as C++, Java as well. Before go through those 3 ways, I'm going to walk through the 3 types of methods we'll be using in Python, also will be in my later examples. One is instance method and is very widely used. In this method, the first parameter used to be a self. Then use these self parameters, we can access one class object variables. Another is called class method. It used to combine with the decorator class method, and the first parameters is an uninitialized class object, which is different than the instant method. The instant method is always be initialized except the init method. Then for class method, this first variable is always uninitialized class object. Sometimes you will use this function to initialize an object and return. The third method is totally different than the first two. It's called static method. So in this method, you are not able to access the variables in all of class object. Hence, you also don't need to create object instant to call this function. You only need this class object and just call these functions. Then first way to implement factory pattern is use if-else. I think it's the most straightforward way to think about how to do that. Here we have class as a parent class defined, and there's one function is given. It has to be abstract method because in its derived class, we want to force the derived class implement this method. It's also defined by static method here because in the implementation of this method, we don't need to access any of the objects variable. And here we have hybrid car derived class as car and the gas car derived class by car, and we implement the calculate class differently. Okay, then how we know which method to call. So here we provide the help functions to take a vehicle type, then if else, then we choose based on the different car type, we return the class object. Then the way to use this help function is we call this function and given the different type. Once we got this object, we just call this method correspondingly. Then we can have different way to calculate cost. You may ask, what happens if we have multiple car type? Then we need to add in more if-else function. This will make these functions really ugly and hard to maintain. To solve these problems, I'm going to introduce the second ways to do that is using dictionary here to totally replace with the if-else block. In the dictionary, all of the key is car type, and its key value will be the class object. Other than that, all the class object will be keep the same. To use this factory pattern, we only need to use this dictionary and put its key there, and we can get the corresponding class object, and it's they have same override method, and it will be called depends on the class, the derived class. In my opinion, there's still room to improve because every time we initialize a new derived class, we need to add this into the dictionary. So next, I'm going to introduce a way to automatically register the new derived types into this dictionary. I call this way as self-registry. In this implementation, I'm implement the dictionary inside of the parent class, and I also do this by relying on the new feature in Python. It's called any subclass method. So this is, I believe this is a default class method, and it just returns the class object, then will be registered the new car type into the dictionary. So this init subclass will be called before we initialize the derived class. I'll talk how this implement later. But one thing to be noted that once we initialize or before we initialize new class, the new class will be automatically registered in dictionary. We also have this get concrete classes. I move it into the parent class. It also defined as class method, such that by given the type from the external outside, we can directly return this dictionary by the type. Oh, sorry, it's not dictionary. We'll return it. The dictionary is mapping the derived class object by given by the type. Regarding with the definition of derived class, there's only one difference is we need to pass in the car type. This time when we define the derived class, after we input the car type, the init subclass will be called automatically. It will take this type and register the dictionary. To use this self-register way, what we have is we need to call the main class, then I will be called the get concrete classes method by given the specific type we want to calculate the class, and this will be return the corresponding class object, and the function will be called purely corresponding by the class type. All right, so that's all about those three ways. Hopefully each ways I explain makes sense, and please feel free to leave your question and comments at the video below. Then I see you in next video.